This is the second video for Unit 0, Introduction to Physics, where we'll be looking at some of the problems that will help us as we go forward this year. The first question that we have here, we're asked to decide what type of graph we have. And the relationship is linear, as we can see from the fact that the line is straight. That is not exponential in any way. Instead, it is a linear graph because the line goes straight up and down. Now, when we look at question B, what is the volume of 6 kilograms of the substance? It might be easier for us to zoom in a little bit here. Draw a line from 6 kilograms and then trace over and see where that would then intersect. Where do the numbers intersect? And we would see that for B, the volume of 6 kilograms would be 4 liters. What is the mass of each liter of substance? So since we are looking at a linear setup here, if we were asked to do that, it would be approximately, rounding up to the proper number of significant digits, 1 kilogram, and that would be per liter if we wanted to look at that. Again, you would probably put that in your calculator and you would find that your numbers are off a little bit, but again, we're rounding to the nearest whole number on that, and that's why your book has a different value. The surface of a rectangle measures at 2.2 meters long and 1.103 meters wide. It might be easier for us to actually draw something similar to that. And so we have a rectangle. Let's try to get it a little bit closer to scale. And that it has a side of 2.24 meters and 1.103 meters. Now, calculating the perimeter of the tabletop might be something a little bit off for you because it's probably been so long since you've actually been asked to calculate the perimeter. Usually most students in physics have been calculating areas and volumes for so long that they forget that to find the perimeter, it is just adding all the sides up. And if we added all of the sides up, we would get 6.686. But now we have to round that to the proper number of significant digits, and that would mean that we would only go to there, since the one with the least number after the decimal place is the 2.24. So ultimately our answer for A would be 6.69 meters. What a lot of students would be able to do is calculating the area of the tabletop, and that's just simple as multiplying the two values of 2.24 times 1.103 together, getting a number of about 2.47072. At least that's what I have on my calculator, and the label would be meters squared. But again, now we have to go with the number with the least number total, And whereas now that 2.24 has 3 significant digits and 1.103 has 4 significant digits, we need to round our numbers so that it's only 3 significant digits, and that would be our answer for that. What is the area of the desktop in square centimeters? That it can be a little tricky, and a lot of students sometimes will forget that they need to do this by converting meters squared into centimeters squared, and that will mean converting from meters to centimeters twice. Now, one could do this all at one step, but we find that doing it in multiple steps, at least at the beginning, is helpful because we can then see that both of those cancel out. It would be 100 times 100, which, again, you wouldn't be too difficult for a person to put into their calculator and go with. And we would see that the answer ends up being a fairly large number of about 24,700 centimeters squared. Number 9 has us looking at something a little bit different that we will be using quite a bit in this class, actually, and that is taking data from a table, putting it in a graph form, and then adding things up. And now this can be a little tricky if you don't do your scaling quite right. And my scaling is, I know, is going to be off quite a bit, actually. And so we have to pay attention to how that scale goes up. I know, though, as I go up, as the line goes up, it will be very close to a linear graph. And again, it's tough to say here and show here over time on a different sheet paper. I was able to do and kind of show in the video. It's pretty darn close to a linear line, as long as you pay attention to the best fit of all the points. And then you're asked to describe the linear, and that is a linear curve, and because it doesn't change, it doesn't have any exponential or parabolic parts to it. And then we were asked to write an equation relating the depth of the water to the tank of the mass. And that is, in a way, finding the slope, or y equals mx plus b, where y is the mass, and that is equal to the mass is equal to the distance times 7.5 kilograms per centimeter. My stylus doesn't want to work there, but that's what you would have. And now it says, what is the slope? And that would be your 7.5 kilograms per centimeter is the slope on which you have here. You know, the y is the value of for mass of water measured at 40 centimeters, not exactly twice. There are some slight variations in your calculations, as you would see here. At 40, and even at 10, we don't see that as a double. We don't see that as a double. What they're looking for is y is, at 20, it's 149, and therefore we would expect that at 40, it would be just a little bit, which would be about 298. It's actually 302. There's some slight variations that one would just be able to say that that's what it is. And there are sometimes slight variations in the data, in the calculations, and that's even if you plotted your graph correctly, you would see some of the dots just not quite fitting on the line just right. And that's what you would have with that. And here we have another one where we're asked to comment on which one's more precise and which one's more accurate. The electronic balance is the one that is more precise because it shows more significant digits. Now, which one is more accurate? That would actually be the triple beam balance because it's closer to the actual value. And you can see that by being off on the very end part here actually shows very little, but we see that it's 1.001, 2.002, and so that one is more accurate, closer to the actual value. And that's one thing that a lot of students forget is accuracy is equal to actual. That's how we usually remember that accuracy is to actual. Now we're asked to add and subtract, and we're going to be asked to do that paying attention to the proper number of significant digits. Here, we again have to just add the two values and then put them in the proper number of significant digits. In some cases, it is again always best practice to add, subtract, multiply, or divide, whatever you have to do, and then change to the proper number of significant digits. And here we would have to get an answer of 0.00289 millimeters. That M is just atrocious. And so, but the one with the least number after means that we would change it to round to that value, giving us an actual value of 0.0029. Again, label of millimeters if I had saved some room. Here we're asked to subtract from that same value. Not that same value, but different values instead of adding them up. And we see that we would get a value of 2100.6. The one with the least number of digits after is the 2103 seconds, and so we would round our answer to 2100 seconds. And ultimately, on the last problem here, we're going to have to actually convert our scientific notation. Might be a little easier to see that. Get rid of some things here. It might be easier to see that if we can write in where we have here. And so we have to convert that over so that we have the same number in scientific notation. It'll make our life a little bit easier. And then a lot of times students will just plug it into their calculator, but it can be done without. And we're again adding these together, if you can plug it into your calculator and it will do some of the work for you, but if you make sure that you remember that why this is giving you the answer that it is, it's because they need to be converted into the proper number of scientific notation. Now, this one with the least number after the decimal place would give us a value of 0.002. Oh, missed a zero there. Didn't think about that. And so we have 0. There we go. Little change there. 97. Well, we need to just have one significant digit after the decimal place, because if we change that, that would actually have 2 after the decimal place. And so what we end up having is 0.0003, or if you wanted to convert kilograms, or if you wanted to convert that, you could still say 3.0 times 10 to the negative 4th kilograms. And on the last one, again, we would need to make sure we add them with the one with the proper number of significant digits, and you will find that it's going to be a little bit different at times, but overall, not too bad. As long as you remember that why that's happening is where you get with that. Now, when you have numbers that are fairly large, you have to pay attention to the number after, again, or after the decimal place. And so your numbers are going to be just a little bit off. We see that we have changed this, so it'll be 52, and that would be to the third. And so now we would have just a much larger value, so we would have to subtract 52, and we would get 5.3 times 10 to the third meters. But since we converted that to out of it, so it would just be 5 times 10 to the third meters, since this should not be there because we converted this out right here, and moving the decimal place over 1 gave us no numbers after the significant digit. So it changes things just a little bit. Our last problem is one that I think most students at least enjoy a little bit more, or at least find a little bit easier, and that is multiplying or dividing within the proper number of significant digits, just because it's a little bit more straightforward. And when it's more straightforward, it's usually easier for everybody. Here you take 2.21 times 100.0, the one with the least number of significant digits is that, and we would end up with, lo and behold, even by just luck of the draw, 221 kilograms times meters per second. And I'll write that out a little bit better there, and so that it looks just a little bit better. So we see kilograms times meters per second squared, which, as we saw earlier, would be the equivalent of 221 newtons. Here, in the next problem, you can convert them into the same number, but when you divide your scientific notation, remember that you're actually subtracting your scientific notation, and so it's going to be just a little bit different, but one could easily, and most students will do, and that is put it directly in your calculator and hit enter. Not the most suggested thing to do, but you find that since you're subtracting a positive, it actually ends up being a large number or a large more whole number, and that you get a value of 5.03817, but which one has the one with the least significant digits? We have 2 right there, and so 5.0, and here we have our values in meters per second there. And on in number C here, we have actually something very interesting with our values. We see that our centimeters squared divided by centimeters will get rid of that 1 squared there. And so you'll actually just end up with centimeters. And so that actually might be valuable to do at the very beginning. We can see that the 1.23 is the one with the least number total. So when we put it in our calculator, we get 162.602. But we need to convert that into the proper number of significant digits, and we will find that it's just a nice even number of 162 centimeters. And the last value, when we multiply our scientific notation, we actually end up adding them together. And so when we put it together, we'll find that our value becomes much larger. As it should make sense, as when you multiply something, it does get bigger. And so we have that, and we get a very large number. But this time, our value with the least number of significant digits is just 3, which is just 1 significant digit. So our very large value of 79,200 gets rounded to 80,000. And this time, because we have kilometers times kilometers, would be kilometers squared. Well, one could also put this into scientific notation and just have the 8 times 10, and we 1, 2, 3, 4, be to the 4th kilometers squared as our answer. I hope that you enjoyed, or at least found some value in looking at these in your preparation for your test, and or maybe preparation for some of the calculations that we will be doing in physics throughout the year.